The recording of this webinar is going to be available on the website also. Let's move further. First of all, just to introduce everybody, Guru Nanak Dev Global University is a new initiative which we just started this year. It's proud to say that it's going to be a university in Dallas with Indian roots. It's the first university in USA with Indian roots. Our vision is to transform students into global leaders through the power of inspired learning and self-development for positive social impact. A lot of work has been done in last 7 months, where we are defining different center of excellences. Within the center of excellences, we are defining the departments and the curriculum. The university, along with this, we also have a Pulse, a magazine that we launch on regular basis. Pulse, which stands for Promoting Understanding and Learning Through Shared Experiences. The 2 volumes are already available on Amazon. We pick different topics in each volume, and we kind of have technical papers in these. Moving forward, the university is being launched on June 20th next year. So we are hosting a convention, Guru Nanak Dev Global Convention 2024, which will be on June 20th. The sessions are outlined here on your screen. Different sessions. It's a 3-day convention along with the inauguration. Day 2 is a technology day, which will talk about semiconductors, big data, quantum computing, artificial intelligence. So different sessions are already laid out. Day 3 is all about collaboration and climate resilience. You can essentially take a picture, scan, and register on the website. The website is gndgu.com. Again, Guru Nanak Dev Global University. Acronyms for that is gndgu.com. Like I said, all our previous webinars are available on our website. Last webinar we hosted, it was on sustainable areas, essentially transforming next-gen urban and rural areas together. We had speakers, Mr. G.S. Gill, Manika Goyal, who were guest speakers. So the recording of the previous webinar is available on our website. Coming to our webinar of the day, which is Smart Water Management Strategies. Our guest speaker is Mr. Anvesh Dasari, who is the VP of Manufacturing for both manufacturing as well as smart cities. Anvesh holds a degree in electrical engineering from Purdue. After getting his degree, he went back to India and joined Efftronics in 2009, kind of evolved in different roles, and now he's managing the R&D development as well as the smart city initiatives. Efftronics has more than 100 skilled R&D engineers. The Efftronics as a company has more than 800. We'll hear more from Anvesh ji more. But under his leadership, the company has brought in different products, be it in railways, be it in smart cities, and we're going to hear today about water management. Anvesh ji, floor is all yours now.
Thanks a lot, Baljit ji. Thanks a lot for this wonderful gathering and online session. And it's been a pleasure to talk on smart water technologies. So I hope I'm audible, and I will share my screen now.
Yeah, you can share your screen. Excellent.
So, yeah. Good morning all, and good evening to folks in India. So Today, I'm going to present about smart water management. Today, the water is one of the important resources globally, and we will understand what are the solutions we are addressing to conserve water and sustain water. So before I start, I will just give an introduction. So I am Anvesh Dasari. I'm working in Efftronics as Vice President. Today, Efftronics is based out of India. It is headquartered in southern part of India, and we have developed more than 100 plus solutions in the technologies of IoT and machine learning. We are focused in domains like railways, smart cities, and smart buildings. We have our own R&D center in India with more than 100 plus engineers coming from different streams like electrical, electronics, and software. So that is about Efftronics. So let me deep dive into the main agenda of today, which is smart water management. If we talk about water, it is the elixir of life, and it is also very important for good health. Even if we look at the Sustainable Development Goals of UN, one of the most important goals today is water. So the Sustainable Development Goals talk about again four important aspects, which is clean water and sanitation. In clean water, the most important goal is to provide accessible water to every citizen. Even as per the standards, providing 135 liters per day is a standard accessible water we have to provide to every citizen. Similarly, again, providing proper sanitation, treatment of water is also very important. So these are the some of the goals which are already targeted for 2030 by United Nations. Now I'm going to talk about how electronics is being part of these sustainable development goals. Today, I'm going to give you examples of three different solutions to meet these sustainable development goals. The first one is drinking water management. The second solution will be sewerage treated water management. The third solution is smart irrigation. I'm going to talk about these three important solutions and how we are going to create impact and how we have created impact using these solutions. First, maybe my talk will be talking with the use cases more in the context of India, but some of these solutions can be taken to other geographies worldwide in a partly or with a customization as well. If we take Indian context, we have got or anywhere there is a source of water. It may be rivers or it may be lakes or it may be any groundwater. That water is pumped and then it is treated. Then this treated water is sent to various elevated reservoirs or ground level reservoirs. Again, these reservoirs are catering to different district metered areas, which is like a colonies or communities. And then it is distributed to individual households. So these are the different sub activities which is happening in drinking water distribution. So now let us understand what are the challenges in each of these areas. If we look at the raw water intake, there is seasonal variation, summers and winters. The amount of quantity of water availability is a concern. Similarly, day by day, because of pollution, the quality of water in these raw waters also degrading drastically. The second stage is water treatment. So as the raw water quality is changing very dynamically, it is also important to have the water treatment plants to be dynamic in nature. Today, if we look at a lot of our water treatment plants, the technology was like we generate the or we design the treatment plant very like 10 years back or maybe 2, 3 years back, and it is only catering to those needs. We are not adopting to the dynamic nature of how the water quality is changing day by day and then adopting to it. The third stage is elevated reservoirs and ground level reservoirs. Again, the water gets contaminated in the pipelines. So are we ensuring that the water it is reaching household is having the right quality? Similarly, especially this is more in context to India, where the timeliness of delivery is also not adhered in all parts of the country. Then the leakages and wastages in distribution and also pollution. The final area is availability of water to every end mile. Today, whether every citizen or every household in the city is able to get the water to his household. So is the end mile connectivity available? Again, if we look at the water wastage or the leakages and water wastages, the last mile is where the 70% of water wastages happen in the cities. So these are the current challenges in water distribution across the world. Now, what we have done is we identified what are the critical parameters need to be monitored in each of these stages, and then deploy some solutions to control these parameters. So like in treatment or in raw water, to measure the quality, we have various sensors like turbidity, pH. Similarly, I will explain this in detail in the coming slides. Similarly, in treatment also, we have all quality and quantity sensors. Similarly, we have quantity and quality sensors as reservoirs, as well as quantity sensors at the households and so on. Now, I will deep dive into the solution. So the solution, what we have built is based on IoT and machine learning. Here, the IoT devices are equipped, or the system is equipped with various sensors like quality, like turbidity, pH, chlorine content, and so on. For quantity, we have level and flow sensors. And for automation, we have valve controls and so on. Again, this solution also uses the latest machine learning and data analytics to have better insights to the data being captured by these sensors. The ultimate objective of this solution is to provide right quality of water, again, right quantity of water at right time, and also reduce water wastages or improve the efficiency of water distribution. So this is the main purpose of developing the solution by Efftronics. So one of the features of this solution is it is a 24/7 continuous monitoring solution. So a lot of places people have monitoring within silos, but now this solution is a continuous monitoring with high accurate sensors. The accuracy of sensors is very important when we deploy these solutions, because when I'm measuring quality of water, the accuracy of sensors is also very important. Similarly, we sample at very frequent intervals. Like some of the solutions in the market, they sample at 1 hour or so. If that is the case, are we able to really identify the wastage of water? So the solution developed is catering to high sampling rate, that is less than a second. And the entire solution can store and crunch millions of data points. Similarly, there is advanced analytics, interactive dashboards. This solution is again 4G, 5G compatible, so that we doesn't need to even have a communication or a copper cable or fiber cables to every geographic location. Again, these generate real-time alerts to the maintainers or the operators of water distribution. And there is automation to reduce the manpower, because again, that is a very important resource which we can conserve as well. Now, sorry. So this is the solution I'm talking about. We have source of water, then we have got treatment plant, then we have elevated reservoir and the households. Here we have sensors at every important location. As I said, quality like turbidity, pH, conductivity. Again, all motors and pumps are measured with energy monitoring. Similarly, there are pressure sensors. There are quantity sensors like flow and level. All these connected to the IoT devices. Again, these IoT devices are connected to the central place using 3G or 4G network. And also, we have the analytics, ML, everything running on the cloud or on-prem. Now let us, this is one of the case studies. This is for one of the colonies of one of the public sector entities in India. So where they have got their own community of more than 1,000 apartments. So where they're able to monitor entire consumption of water, as well as they're able to create a billing and all that. So now, as I talked initially, let us address each of the stages in water distribution. First is intake well or the source of water. Here, we are measuring 3 or 4 important parameters. One is what is the intake of water we are taking from the source. Similarly, what is the quality of water like turbidity and pH? Using this sensor, the software can recommend how much alum need to be mixed in the water to reduce the turbidity. In some of the areas, the turbidity is so high, we have to introduce alum before even giving it to the treatment plants. Then we also monitor the energy consumed by these pumps, because if those are not efficient enough, we again doesn't have, we will have high power bills and increase the operation cost. Here, we are also deploying like ML technology, machine learning. We know how the pumps are consuming power. There is a signature of pump operation. Those signatures were fed into our anomaly detection algorithms using machine learning. And those anomaly detection algorithms are able to predict if there is any failure to the motor. So this will also enhance the availability of water and also reduce sudden outages or sudden breakages of these motors and pumps. The second stage we have got is water treatment. For water treatment, again, we also measure what is the inflow and outflow of water treatment. Similarly, we measure the quality parameters like free chlorine, turbidity, and pH. Similarly, here also the treatment water again is being pumped to the elevated reservoirs through pumps. Here also we will be measuring energy, pressure, which is important to maintain the head, and also outflow of water. So using this, we are ensuring right quality of water is being sent out of treatment plant. We are also ensuring the pumps are energy efficient. We are also ensuring the required pressure is being set so that the water can reach the end mine. This is also showcased in real time with a live simulation with all the treatment plants along with its related elevated reservoirs and so on in real time. So this will help the operators or the district or the municipal bodies to understand how the water distribution is happening in real time. Similarly, this is one of the alerts being generated at the treatment plant. There was a huge rise in the chlorine content. Generally, it should be around less than 3, but suddenly it has been shoot up to 4. Those kind of alerts are generated automatically and sent as an alert both through mobile app and as well as SMS to the operators so that they can act immediately. Similarly, this is the pump efficiency where we can see the voltage, current, active power, power factor, all important parameters of a pump. And this helps in proactive maintenance or preventive maintenance of these pumps. Again, we can also see the live status of all the parameters on their mobile phone as well. Let's say there is a city commissioner who wants to see what is happening to my water distribution, whether entire network is intact, or if he wants to see it in his mobile, he can see it on his tablet or PC as well. Again, based on the persona of the user, these screens are redesigned. Let's say the commissioners will get MIS reports. Similarly, the local operator or an engineer will get more detailed report. So those kind of dashboards are created based on the persona of the user. And similarly, the summary reports, like what is weekly consumption, monthly, how it is performance, weekly, daily, monthly basis, so that we can improve whether the system is improving or whether it is degrading and so on. The third stage we have is elevated level reservoirs or ground level reservoirs. Here, we are monitoring flow for quantity, level, again for quality measurements, again chlorine content. Here, so what is happening is water is coming from the treatment plant and reaching the elevated level reservoirs. In some of the pipelines, we have noticed that there is a chlorine decay. That means the chlorine content is reducing. At those instances, the software again can trigger the operator at ELSR again to ensure that there is a chlorine dosage again done at the elevated reservoirs so that the citizens can get right quality of water. So here, this is one of the use cases where the water is flowing out of the tanks, which is wastage of water. So this is measured through a level sensor on top. It is an ultrasonic sensor. Similarly, this is whether the people are periodically maintaining the reservoirs can also be seen through the sensor data. Generally, in these ELSRs, there is a separate wall called score wall, which is opened when they want to clean the reservoir. Whether the people have really cleaned it or not can also be verified with the sensing data. Similarly, as we are measuring both outflow of the treatment plants as well as the inflow of these reservoirs, we can identify how the wastages or unaccounted for water is there in this distribution. So here we are fusing the data of sensors with analytics to understand this wastage. And using this data, we can identify which pipeline or through which route the wastage is more. And once the people can act on it, we can reduce the wastage of water. So in one of our deployments, by deploying this solution, the unaccounted for water has been reduced from 32% to 5.5%. This is not only the success of the solution, we have to also appreciate the efforts taken by the customer as he acted with the data and taken a corrective actions immediately. The other important benefit of this solution is today the water distribution infrastructure is designed by the city officials by forecasting next 2-3 years or so. But some places, the people can get, the migration of citizens can be so high in some parts of the city, and where the demand for water will be very high. Similarly, in some geography in the city, the demand may not be up to mark. But whether the infrastructure which we have created much before, does it really address this? Or are we really catering to the needs of the citizens? To understand this, we also created a machine learning based algorithms to identify the demand versus supply, whether the water supply is sufficient for the demand of the citizens. Even this can be identified through the softwares and machine learning. The other benefit is in during crisis. If there is any crisis because of any floods or anything, this kind of real-time monitoring solutions with IoT will help the city officials to manage the water efficiently to all the citizens in the city. Even this was one of the case studies where there were some of the treatment plants got submerged, but still the city officials were able to give the city water with the other remaining treatment plants available. So from the treatment plant, we came to elevated reservoirs. Again, from reservoirs, the next stage is district metered areas or the colonies or the citizens. The one of the important KPI is whether they're distributing the right quantity of water as well as timeliness of delivery. So that is again monitored as a KPI for every metered area or the district metered areas. So this is why like plan versus set schedule. What is the actual planned distribution time and what was the actual distributed time? So this will improve the efficiency of operations and bring in accountability of all the users or the operators. And this will improve the customer or citizen services, the quality of citizen services. Finally, the final stage is household supply. Here, we have got water meters. These are again ultrasonic, very reliable water meters, which can even withstand more than 70 degrees, up to 70 degrees centigrade, it can operate. So here we can see the consumption apartment-wise, house-wise. Again, we can create billing to that. Even we can give these consumption reports to the users also so that they can understand how they're consuming water, and even they can start understanding how the trends are, how they can reduce the wastage. Here even we have like more detailed granular data, like how the kitchen is consuming, how the washrooms are consuming, more detailed graphical representation. So this helps even users to start thinking the importance of water and conserve the water. Similarly, it is like a building wise, apartment wise, house wise, we can give these reports. Again, if somebody has any kind of problems, they can log the call logs, and again, city administration can act on this so that the distribution system can have better service levels. All this is maintained at the command control centers, and they can see the live data, live status of everything, so that they can again any alarms will be generating, so that if there is more quality more wastages, it will generate an alarm. If there is a schedule mismatch, it will generate an alarm. So it generates a lot of alarms and notifications along with live dashboards. So Again, this got recognized in some of the international journals. So this is one of the solution I was talking about, water distribution. It is for drinking water. The second solution I'm talking today is about wastewater management, where the main goal is zero discharge, so that the treated water is sent back from our premises to the outside. This is very important. Even for big, large communities, this was again done for one of the big thermal plants, because they have to ensure the water is discharged adhering to the pollution controlling board guidelines. Again, also it is important to bring accountability to wastewater itself. So here on to the right, we can see the different sensors. It is called multi-parameter analyzer, which is again connected to an IoT device. So this analyzer measures different parameters like COD, BOD, pH, total dissolved chlorine, or similarly turbidity. All these parameters in real time are again captured by the IoT device, and that is sent to the central dashboard. Here, we generate alarms based on the threshold. If some threshold is more than the required threshold, we generate alarms and people act on it. So we can see the trends, how it is, like periodical, like monthly, daily, weekly. We can see all this data. The third solution I'm going to talk today is on irrigation and making it smart and autonomous. It is very important to have a beautiful landscapes, not only for healthy living and also for healthy mind. So how we create this eco-friendly smart irrigation? So what we have created is an autonomous system which adjusts the watering schedule of plant based on not just the water, based on the weather, the soil condition, as well as the other water parameters also. Now let's deep dive and understand the solution. So here there are three subcomponents. The first one is sensing. The second is analyze and create a decision support system. The third stage is controlling, automation, and becoming it autonomous. So you have heard about autonomous cars. Similarly, we can make the irrigation system itself autonomous. Let's see that. So here, the first important device we have is a evapotranspiration station. This station is equipped with different weather sensors to understand how the weather is, how the weather parameters are. Then there are IoT devices to monitor the soil moisture. Then we also have some IoT devices to control this irrigation system. The fourth aspect is everything is available on your mobile as well as central software. So this is the system we have. This is the evapotranspiration station, which is monitoring the rainfall, wind direction, wind speed, direction, similarly the cloud clearance, all these parameters. This data is again sent to the central server. On the other hand, we have IoT device monitoring the soil moisture and temperature. Again, there are valves which can control the drip irrigation automatically on and off. Again, a water meter to understand how much water I'm consuming for this drip irrigation. Again, controlling the pumps through on and off. So here, this is that water meter along with the wall, just for the understanding. Again, we can also see the pressure sensor on top. whether the required pressure is being maintained by the motor, and all this sensing data is available at the live central place. Now, the system is having intelligence. First, it is taking inputs from soil moisture. What is the current soil moisture level? Then it is also having a schedule. Let's say I have to water every day morning 6 to 8 a.m. At that instance, it will ensure what is the soil moisture level. Let's say in the night it has already rained, then it is no meaning to again water those irrigation or plants. So based on the current level of moisture and also based on the schedule, the system will be intelligent enough whether to schedule or the switch on the motors and valves. If not, it will not switch on them. Similarly, once the watering is done, the system is also taking a feedback whether the required soil moisture is being given to the plants. Even the next stage, what we can even evolve the solution is based on the type of plants, we can also ensure what is the required moisture and then even control the water based on the type of plantation we have. So this is the complete autonomous solution. So with this, we are consuming water because we are not watering when it is not required. We are saving the energy with automation of pumps and valves. And it is also a great comfort to the operators because it is being completely autonomous. So this is deployed at multiple places. Like this is also important for national highways where they want to have a median with irrigation, where they want to have like today in India, we are having, or even in a lot of places, lots of kilometers of highways where the central median can have a lot of greenery. So that can have a plantation with this kind of autonomous irrigation system. People doesn't, it's very easy to deploy and maintain this plants and trees across the highways and other geographies. So these are the some of the solutions we have done to conserve the water and to achieve our sustainable development goals of 2030. Thank you all.
Excellent. Amazing insights, Anvesh. Really kind of you delve deep into all the three different applications of water management. Anvesh, there were several questions that came up, and let's kind of go through those. So first question, Anvesh, that came up in the registrations is, could you talk about different IoT sensors that are available? I'll club two questions together. So what are the different IoT sensors available? And this other question is, how to choose the right IoT device?
That's very good question. There are different sensors today to measure a lot of parameters. The quality of sensors is evolving day by day, and there are a lot of sensors for quality. As I said, there are sensors like turbidity, pH, chlorine, conductivity, temperature. There are a lot of sensors. Similarly, for quantity measurement, we again have different sensors like flow meters, again level sensors, and so on. The sensors and are evolving day by day, and the accuracy of measurement is improving significantly. And the other important evolving is the power required to switch on these sensors is very low. Even they are coming up with 10 years battery backup so that we doesn't need to even provide any external power to these sensors. The second important question is how to choose the IoT device. So the it the choice of IoT device should be based on the solution we want to or the end objectives we want to achieve. Today, the same IoT device will not fit all kinds of applications or the end goals. So let's say if I'm talking about I want to monitor the water treatment plant. So the data should be very granular. So I need more sampling rate. Then if I talk about water, to know the quantity of water at household, then the data doesn't need to be very granular. Even a 15 minutes or a minute level interval is sufficient. So the device where the end application or the objective is very important to choose the IoT device. Similarly, if we talk about even the connectivity, some IoT devices come up with 4G, so or 5G, or some need to be wired because in some locations the data need to be in real time. In those cases, we have to opt for fiber or dark fiber. So the choice of IoT depends on the end objective and the solution or the goals we want to achieve.
Excellent, excellent. The next question, Anvesh, is there's a lot of data crunching that's happening, especially when we're looking at artificial intelligence. AI is moving from cloud to edge. Could you kind of shed some light on this, how the data is being crunched, where it is crunched, and give some examples?
Yes, that's very important. Today, as you rightly said, Baljit, the artificial intelligence is not just located at command control centers. That is now coming towards edge. Let's say one of the important, let's say today we are monitoring pumps. They generate huge amount of data because if I want to monitor or predict the failure of these pumps and motors, we need to crunch at an interval of 2 milliseconds. That is the sampling rate we are talking about. If we want to send all this data to the cloud or the central place, we will be consuming huge amounts of bandwidth. So the other important solution today is we can deploy the small edge computation in the IoT device itself so that it will do the initial level of some kind of anomaly detection, some kind of basic filtering, and then this data is sent to the central place to do a bigger picture of bigger machine learning and analytics. So definitely machine learning is moving towards edge. And again, the important thing is the IoT devices with the power of GPUs and all is becoming more powerful and they are able to even have ML deployed in these devices.
Okay, excellent. And Vijay, a question came up is about the energy consumption of the sensors and your vision to reduce this consumption.
That's a very good question. As I said, the energy consumption of sensors is reducing day by day. So they are like less than milliamps. And today, in some of the sensors, they are coming up with a battery powered, which can last for 10 years and so on. The other thing or other thing, what we also do to conserve consumption is, let's say, in IoT device, there is a concept called putting the device in a sleep mode. Let's say there is no distribution at all. There is no water is flowing in the pipeline. Do we still need to measure for every second? It's not. At that instance, we put the sensors and IoT devices in a sleep mode to conserve the power consumption and only wake the devices when the measurement is required. So this is how even the power consumption is also being conserved or so that we can reduce the power consumption or energy. Yeah.
Excellent. Next question, Raji, is there's a lot of cyber crime happening. How is cybersecurity taken care when we are implementing IoT, where data is going from factories or a solution outward to cloud and all?
Oh, sorry. The cybersecurity is very, very important. because today we are talking about real-time monitoring, even real-time control. So cybersecurity is very, very important. So we need to have there are a lot of standards for cybersecurity. The IoT devices need to be equipped with these kind of standards. And even as Efftronics, we are like a 27,001 certified company. And also our devices and softwares are even tested for lot of vulnerability assessments and penetration tests so that somebody cannot intrude into this data and so on. Again, that need to be even much more emphasized, and much more efforts need to be put in that aspect.
Excellent. Next question is, how is the high data rate handled? So could you, I know you touched on this on various slides also, but if you can recap, how is the high data rate handled from the device till the cloud, all the crunching?
So basically what we do is there is some kind of sampling which happens continuously in the IoT device. And there we have built some algorithms to send the filtered data or some relevant data to the cloud. So that basically we are, let's say if there is a concept of tolerance, let's say we are measuring continuously the level of water, but the level is constant. Then I doesn't send every millisecond or second. I will only be sending whenever there is a tolerance level change. So that is one of the methods to save the bandwidth. Similarly, if I'm measuring 2-3 parameters together, can we create a third parameter, which is a conclusion of these 2-3 parameters, and send that single parameter to the cloud. So inferred data. So that is another way of conserving the bandwidth. So these are the different techniques deployed in IoT devices to save the bandwidth and conserve power. Sorry, power, conserve bandwidths.
Yeah.
Yes.
So next question and the final we'll take is, Anvesh, what are the challenges to implement IoT in any solution?
Basically, one of the challenges is the when we deploy any IoT solution, we have to have a clear vision and clear benchmarks what we want to achieve through the solution. So if we don't have the purpose in place or the KPIs what we want to achieve, the real intent of this IoT deployment is lost. Is lost. The other important thing what we have noticed is people are still acting based on intuition, not really looking at the data coming from this IoT devices. So what is important is when we have this IoT system in place, the users should start consuming this data and start taking data-driven decisions. Then the system will, the users can see the real benefit of the system.
Excellent, excellent. Final question from my side, Anvesh, is you have so many different solutions. So could you kind of recap all the different solutions, major ones from Efftronics for our listeners?
Definitely. In a nutshell, if I talk about Efftronics, we are an IoT-based company. We develop different IoT solutions to different domains. This includes smart railways, where we want to reduce the accidents and increase the speeds of train. That is one of the objectives with which we are working in railways. We also want to ensure or reduce the downtime of assets, where we are working more on predictive maintenance. Today, predictive maintenance is one of the major area we work on for various verticals. like railways. The second important area we are focusing is on smart cities, where we are working on intelligent transport system to reduce the travel time of citizens. Similarly, we are having solutions for water, where we want to have smart water solutions to conserve water. And similarly, the third area is smart buildings, where we want to create a better experience to the users in the buildings by conserving the resources as well as creating a better living experience. So these are the areas we are focusing in Efftronics. And thanks a lot for joining today. Thank you.
Excellent. Thank you, Anvesh. Amazing insights that you've given on water as well as the other areas where IoT and artificial intelligence can be implemented. An amazing journey of Efftronics. I wish you all the best, and we look forward to having you again in future sessions. Recording for this session will be available on our website. Again, thanks everybody, and see you on our next webinar. Thanks, Anveshji.
Thanks, Baljit ji, and thank you all for joining today. Thank you. It's a pleasure.